Okay, the parametric equations of the curve C are x equals 2 over t and y equals 4t. Show that the tangent to C at the point P with parameter little p has this equation. Okay, so first thing we'll deal with here is obviously we're going to write down our parametric form equations here. So x equals 2 over t, y equals 4t. And because we want the tangent, we've got to think about working out dy by dx, yeah? So we're going to differentiate parametrically. We're going to do parametric differentiation here because we've got x in terms of t, y in terms of t. And the first thing you should do really before you do any differentiation is rewrite this as 2t to the power minus 1. Okay, so take that t up because it's going to be easier then to differentiate. Rewrite that then as y equals 4t. Okay, so then we differentiate with respect to t. So here we've got dx by dt. Well, bring that minus 1 down and times it by the 2. So that'll be minus 2 t to the power minus 2. Yeah, you can bring that power down, reduce it by 1. So that can be written then as minus 2 over t squared, yeah? Okay, because it's negative power, you can take it down. So that's what dx by dt is. But remember, we want to establish what dt by dx is for this to work. So we need to flip this, so I get minus t squared upon 2. This one's easy to do, y equals 4t, so dy by dt quite simply is 4. Okay, right, so let's then use the chain rule. So using the chain rule to get what I want dy by dx, and dy by dx, well, dy is on top, so dy by dt, dx is on bottom, so times dt by dx. Okay, so dy by dt is 4, and dt by dx is minus t squared over 2. So my dy by dx is, well, if I times these, 4 on top, 2 on bottom, so 4 divided by 2 is 2. So put the minus there, so you get minus 2t squared. Okay, that's what my dy dx is there. Now, it says then, show that the tangent to C at the point P, okay, now this is the important bit then you've got to consider, with parameter little p. In other words, okay, we can say at the point P, okay, at the point P on this curve, the parameter is little p. So remember, parameter, we use the letter t in this question, yeah? The t is the parameter, but they're saying at the point P, the parameter is little p. So in other words, at the point P, the parameter t is equal to little p. So that enables us then to work out what dy dx is. So dy dx will equal to, well, you put little p in there then, yeah? So we've got minus 2, so t becomes little p squared. Okay, so that is the gradient, okay, of the tangent. Now to get the equation, okay, because that's what they want, the question, yeah? Show that the equation, to get the equation we need a point as well, don't we? And the point, of course, then we'll get by using the x and y values. So remember, we can back at the top, x is 2 over t and y is 4t. So x will be 2 over little p, okay, because t is equal to p. So x will be 2 over little p, and y is 4t, so that'll be 4p. Okay, so in the equation, remember the equation formula is y minus y1 is equal to x minus x1. Okay, so we just sub in then those values that we've got. So y minus 4p, because that's what the y value is, equals to my gradient, which is minus 2p squared, x minus then my x value, which is 2 over p. Okay, So I've got y minus 4p. Let's expand this bracket then. Minus 2p squared times x is minus 2p squared x. And minus 2p squared times minus 2 over p. Well, minus times a minus is a plus. 2 times 2 is 4. And p squared, but then divide by p is p. So, if I take that minus 4p over, I get exactly what they want. Okay? Right, in B it says the tangent to C at the point P passes through the point 2, 3. So this tangent passes through a particular point. Show that P can be one of 2 points and find the coordinates of each of these 2 points. So what's important here about this tangent is appreciating that it actually goes through a particular point. It goes through this point 2, 3. So what you could say is, since tangent goes through 2, 3, then the point 2, 3 must satisfy the equation. In other words, it'll work in this tangent equation. So sub it in, it'll work. It'll work in here for the value x and y, 2 and 3. So y will be 3 and x will be 2. It'll work because it goes through that point. So then if you tidy that up again, you get 3 minus 4p squared plus 8p. And you can see then that you get a quadratic. So you get 4p squared minus 8p plus 3 equals to 0 if you get everything to the left hand side. Now you factorize this, right? So I'll give you the answer straight away to factorizing it, but we would get this, right? So therefore then you've got two things equal to 0. So either 2p minus 3 is equal to 0 or 2p minus 1 is equal to 0. So p would equal to 3 over 2, or p would equal to 1/2. And then if p is equal to 3 over 2, you can then work out the coordinate. Because remember, you sub it into this here, yeah? So when p is 3 over 2, if you sub it in there, you'll have 2 divided by 2 over 3, okay? And that will become 4/3, sorry, 6. And if you put a half in, you'll get 4/2. And you sub it into the values x and y here.